we
Let's
used to.
look at how a macula Pitts neuron can be used to implement a logical AND gate. An AND gate outputs are 1 only when both inputs are 1. To model this with the MCP neuron, we assign two binary inputs x1 and x2, each taking a value of 0 or 1. The neuron simply adds these input values. If both the inputs are 1, the sum becomes 2. For any other combination, 0 and 1 or 0 and 0, the sum will be less than 2. So we set the neuron threshold to 2. If sum reaches or exceeds this threshold, the neuron fires and outputs a 1. If it does not, the output remains 0. This shows how a simple MCP neuron can perfectly replicate the behavior of an AND gate using just additional a threshold. Now OR gate. Let's see how an MCP neuron models a logical OR gate. An OR gate outputs a 1 when at least one of the input is 1. Again, we take two binary input x1 and x2. The neuron adds the input values just as before. If either x or x1 or x2 is 1, or if both are 1, the sum will be at least 1. So we set the neuron threshold to 1. If sum is 1 or more, the neuron activates and outputs a 1. Only when both inputs are 0 does the sum stay below the threshold, giving an output 0. This demonstrates how the MCP neuron also implements the OR gate simply by adjusting the threshold.